this video, we're going to talk about exercises from section 2.3 of Apex Precalculus, domains of functions. The first question asks us, what does it mean if x equals 2 is in the domain of f of x? It means that the input x equals 2 generates an output in the set, the codomain. The subset of it is called the range, and we drew that out earlier. So that there is a ordered pair on the graph of f of x at 2 f of 2. So we don't specifically have to have a graph though. We could have, here's our domain, here's our codomain, here's our range in here, and we've got 2 maps to f of 2 somewhere over here in the range. What does it mean if x equals 4 is not in the domain? It means that it's not a valid input. So it would do something like cause division by 0, cause the square root of a negative number, cause the inside of the log to, or the base of the log to not be positive. So one of those things would not generate a valid output. The domain of f of g of x depends only on the domain of g. That's false. It also depends on the composition f of g once you're done. So if I have f of x is equal to 1 over x plus 2, and g of x is equal to x plus 3, that g is going to have a domain of all real numbers, but that's not going to be the domain of f of g, because when I do f of g of x, I stick it in here, I'm going to have to look at this new function that gets generated after I've looked at g to make sure I can plug g in and say, oh, that means that x can't be equal to -5. Because I'd get -2 here, and -2 plus 2 is 0, and I'm not allowed to divide by 0. So domain of f of x divided by g of x depends only where g of x is equal to 0. It's also not exactly true, because f of x could be something that's not a polynomial. It could be something that has a restricted domain, such as a square root. So if I had something like x minus 2 over x minus 5, then we have to restrict our domain to x greater than or equal to 2, but not equal to 5. There's an open circle there. So our domain is going to depend on both the numerator and the denominator. They gave us an example of what I just talked about in number 4, right there in number 5. So number 5 or number 6 could have been your counterexample for number 4. For 5 asks us to find the domain of 3 minus x inside a square root sign in the numerator, x plus 9 in the denominator. So x is going to have to be less than 3 and not equal to -9. Less than or equal to 3, not equal to -9. So how did I get that it was less than or equal to 3? I said 3 minus x. 3 minus x has to be greater than or equal to 0. I'm going to subtract 3 from both sides. -x is greater than or equal to -3. Divide by -1. When I divide by -1, I need to change the direction of the inequality. X less than or equal to 3. X plus 9 cannot be equal to 0 since it's in the denominator. So x cannot be equal to -9. This is an and statement. Both parts have to be true. So I'm going to eliminate -9 from this area. So my domain will give me -infinity to -9, not included. Give me -9 to 3, 3 is included. Number 6, square root of x plus 11 over x minus 11. So we have x plus 11 is greater than or equal to 0. X is greater than or equal to -11. But we also have x cannot be equal to 11 from the denominator. So we've got -11 greater than or equal to, not equal to 11. And there it is. -11 to 11, union 11 to infinity. Now we're going to look at natural log of x minus 6 over 2x minus 26. So the inside of the log has to be greater than 0, and 2x minus 26 cannot be equal to 0. X has to be greater than 6. 2x cannot be 26, x cannot be 13. So we need to be greater than 6 and not 13. Strictly greater than, not including the point. There's 13, not including that point, and I need to be greater than 6, but not 13. So I don't color in that open circle. That means that our domain and interval notation is going to be 6 to 13, union 13 to infinity. 8, 2t over root t minus 5. Now be careful because the square root is in the denominator. Normally we'd say greater than or equal to 0, but we can't say equal to 0 because it's in the denominator. So t minus 5 has to be strictly greater than 0 in this case. T has to be greater than 5. There's no restrictions on the function in the numerator. So this is it. 5 to infinity is my domain in interval notation. 5 is not included. 9, natural log of the square root of x plus 3. So let's start off with the fact that x plus 3 has to be greater than or equal to 0, but I'm not allowed to have 0 inside of a log. So x plus 3 has to be greater than 0. So x has to be greater than -3. So we get -3 to infinity. Number 10 says theta cubed plus 4 theta squared minus 2 theta plus pi. This is just a polynomial. There's no division by my variable. There's no variables inside of square root signs. There's no variables inside of logs. My domain here is unrestricted. I can stick any number in that I want and calculate, get a real number answer. So we're going to get -infinity to infinity. Number 11, log base 3 of x minus 4 over log base 3 of 2x. So this is going to be x minus 4 needs to be greater than 0 and 2x needs to be greater than 0. And two x cannot be equal to 1. Okay, so I can't have log base 3 of 1 is going to be 0 down here. I can't do that. So x is not going to be allowed to be 1/2. X has to be greater than 0. X has to be greater than 4. Well, all of these have to be true at the same time. So let's look at the number line. Greater than 0, not equal to 1/2. So 1/2 is out here somewhere. And greater than 4. Well, none of these were greater than 4, so we're just going to erase that. And we're going to say greater than 4 satisfies all the conditions. So my domain here is going to be 4 to infinity. X over log base 2 of 2x minus 1. Have 2x minus 1 has to be greater than 0, and 2x minus 1 cannot be equal to 1. So 2x is greater than 1, x greater than 1/2. 2x cannot be equal to 2, x cannot be equal to 1. So we have 1/2 is 1. And there we go. The numerator was unrestricted. So our domain is 1/2 to 1, union 1 to infinity. Number 13 says f of x is equal to ln of 4 minus x squared. 4 minus x squared has to be greater than 0. We just did these types of inequalities like this. We're going to factor and say this is negative x squared minus 4. It's greater than 0, so x squared minus 4 needs to be less than 0. X plus 2, x minus 2 needs to be less than 0. Here's our number line, -2 and 2. Positive, negative, positive. Need less than 0. In circles. In here, my domain is going to be -2 to 2. That was number 13. Number 14 asks us f of x is equal to ln of x squared minus 4. This is going to be the same domain here. No, it's not. It's going to be slightly different. So x squared minus 4 is going to be greater than 0. X plus 2, x minus 2 is going to be greater than 0. So we have -2 and 2, plus, minus, plus. We want greater than 0, so we want the positive part here. So we have -infinity to -2, union 2 to infinity. (15) says the square root of x plus 3 squared minus 4. We're probably going to want to expand all that out. X squared plus 6x plus 9 plus 9 minus 4 is going to give us x squared plus 6x plus 5 needs to be greater than or equal to 0. We're going to factor that. X, 1, 5, 1. So that gives us zeros at -5 and at -1. We're going to be allowed to include those because it's greater than or equal to. And this is plus, minus, plus. And we want what is greater than or equal to 0. So we're over here and we're over here. -infinity to -5. It's a closed bracket. Union -1 to infinity, like that. finishing up the problems here. Number 16. F of x is equal to the cube root of x minus 2 to the third plus 1. So we do not have any restrictions like we have on square roots with cube roots. We can have positives or negatives in there. So my domain here is going to be all real numbers. There's no restrictions on this when I simplify it. If I would simplify it, but it's a function that has a domain of all real numbers, a function with a domain of all real numbers, its intersection is going to be all real numbers. All right, that is it for this section. We come back next time, we will talk about graphs and graphing, section 2.4. See you for the next video.